Yeah, thank you. Hi, good afternoon. Thank you for coming to the One North Festival, and thank you for joining my talk today. And I hope you all had a great day so far. So I'm Sula from Cybersecurity Cluster, Institute for Infocom Research, A*STAR. And today I'm going to share with all of you a very exciting topic, which is Bitcoin. But what is more important and the focus of my talk is the technology behind it, the blockchain, and why it is so fascinating and everyone is looking at it. Well, to start, I will give some very basic information on Bitcoin. So in October 2008, there is a 9-page, very short and concise paper published online by people named Satoshi Nakamoto. So he designed this Bitcoin framework and published it on the forum. However, up to today, his true identity is still unknown. Well, someone speculated that he may be Japanese from the name by natural. Someone says, well, according to the way he wrote his paper and his forum posts, some of the words he used are actually quite British. So he must be a British guy. But another group of people actually analyzed the time he actually posts online or the thread and whatsoever and says, well, during the mid-time of Central American time, this guy never posts anything. So perhaps he's from America or Canada. But still, up to now, no one knows who exactly he is. Another interesting fact is that it is believed to know that this guy actually owned roughly 1 million Bitcoin up to today. So how much exactly that one worth? So you can see I already crossed it. 2 weeks ago, when I prepared a slide, it's 3.1 billion. 1 week ago, it's 3.9. And just now I checked, it's 4.4 billion US dollars. So yesterday, actually, the Bitcoin has reached the historical high of 6,000 Singapore dollars per Bitcoin. Well, I guess this is one of the reasons this guy wants to keep anonymous. Well, talking about Bitcoin, then we need to look at what is the underlying technology. There are tons of technologies from math, from network, from computer science. But here I want to talk about the two core fundamental information that you need to know. One is about hash function. The other one is public key cryptography. So I may start from the right side. And you may be more familiar with that about digital signature. So it's just the mimic of the traditional way we sign on a paper, but doing it in a digital way. So with doing that, you can actually provide the integrity and authenticity for whatever you have signed for. So this one is actually used for all the transactions, the blocks, to protecting its integrity and authenticity. Coming to the left about the hash function, maybe not many of you are familiar with that. It is actually a set of, mass computation or algorithm, such as with given an input, let's say a big data, you throw it into this function, and it outputs a series of strings which looks random. The nice property of this hash function is that it is extremely easy to compute the output, but given the output, it is very difficult to reverse it and to identify the original information. So the key point here, the function is used during the mining process. I believe all of you heard about mining and how to obtain the Bitcoins. And also used for the verification, how people are assured that all these transactions or all these blocks are actually well formed. Last but not least, about the basic information is that with all this technology supported around Bitcoin and blockchain, how does the people around the world actually agree on what other people is writing in there? So we need a consensus protocol. So basically, it is actually a set of rules that all the participants across the network need to follow. That, for example, how do you actually form a block? Which one you need to come first, what information you need to list there, and what information you need to provide. Second, how do you validate a block? When you create it, you need to validate it by someone else. Also, it has some rules apply on the transaction integrity and authenticity. How do you actually form the digital signature? How do you actually chain the blocks together? Well, with all these three basic information to summarize, so the technology behind Bitcoin, which is blockchain, it is a distributed ledger. It is a database for you to record information, to record the transactions. The nice property of that, it only allow you to continuously write an input to the chain, but you cannot never change it. You cannot reverse back and change whatever. This functionality is actually supported by cryptography. As I mentioned, hash function, digital signatures. It provides a secure, authenticated transaction records. And all of this is wrapped around a consensus protocol that allows the people around the world, around the network, to agree what everyone else is doing. Well, this is pretty much I want to talk about Bitcoin. What is more fascinating is that how exactly is a blockchain and how it is going to change our life. So before I dive into that, I give quite a simple example about how exactly blockchain looks like. This is a simplified version. It doesn't reflect the exact format of that, but it actually contains the key points here. So to separate the words, blockchain, it forms like block and chain. So block is relatively easy to understand that it contains all the transactions happen during a past period of time. For example, here I list about 4 blocks. Each of them got some, in the middle chunk, which is the most intensive part, different transactions and their identifier whatsoever. Well, for each of the block, if you look at the very top, there is a block ID which labeled in black. For example, the first one block ID is 21DF. It's just a random number. Moreover, it actually has a red part, which is the previous block ID. So this is where the chain comes into play. So each block is actually linked to the previous block. So that means whenever you're going to create a block, you need to include some information about the previous block. So in this way, you actually form a chain. Well, at the bottom here, I have a big arrow. So this chain is always evolving along the time. You cannot turn back. So with all this basic formation of a block, here I'm talking one of the most important thing about blockchain is how you actually do a mining, or how do you create a block. So here you look at 3 big parts on this slide. At the very top, there is a cloud-shaped thing. It actually is a pool of unconfirmed and unordered transactions. For example, the transactions happened in the past 10 minutes. Everything is put there. In this central left is the same as I showed in the last slide. It's the current blockchain. On the right side here, maybe you cannot see, let's assume there are 3 miners, miner 1 and miner 2 and miner 3. They are going to compete with each other, do a mining. So what they do is, the first step is to pick those unconfirmed transactions from the pool and form the basic block format. That is, you have to have a previous block ID, which is the block force ID here. You list a sequence of transactions. Maybe I use this one, it's easier. This one. You list a sequence of transactions. Here, there are 2 important things. First of all is the block ID for this current block. I leave it as unknown because you are going to compute that. The other information is the nonce here. So this is actually the most fundamental thing that people need to compete with each other. The miners need to guess a random value, or we call nonce, and throw in this whole block he has created into the hash function and do the hash computation. You remember that at the first slide I said, after the computation, you will come out with the random output. And for Bitcoin, this output is actually is regulated, that the output must lower than a certain value, which we call target. So this is hard-coded into the whole system. So because the difficulty of this hash function, people have no idea what exactly this nonce is. The only way to do so is by random guessing. So whoever has the most computational powerful machines around the world who may have a slightly higher chance of quickly finding the nonce. So people pick random transactions, form the blocks, and the very last step is to guess a totally random nonce, throwing everything into the hash function algorithm, and see the output whether it meets the target. This is how people actually mine the block. And a successful miner will get rewarded. For today, each one will get, for each successful block mined, that means you are the fastest one in the world, you will get 12.5 Bitcoins rewarded. You can multiply 6,000 Singapore dollars, you know roughly how much is that. But the chance is that for our common people, it's extremely difficult to get that. You need tons of CPUs and GPUs and build a warehouse and do so in order to win the mining process. Well, talking about these fundamental technologies and information about blockchain, the second half of my talk is actually focusing on how this one will affect our life. So from my point of view, I actually divided the blockchain innovation into 3 categories in a layered fashion. The fundamental one is about a theory advance. So there are a lot of researchers, most likely from universities, they are looking at the Bitcoin itself, whether the Bitcoin itself is secure or whatsoever. Second is looking at what we call altcoins, that means alternative coins. Up to today, there are more than 200 different types of cryptocurrencies has been invented, and they all have their own properties or whatsoever. And last but not least is that a large pool of researchers is actually looking at the blockchain and the Bitcoin efficiencies. So let's assume that if we are going to use Bitcoin for all kinds of transactions in the future, it must be extremely fast and scalable. To name a few numbers, at the moment, for the Bitcoin blockchain network, the maximum capacity is it can process roughly 7 transactions per second. 7 transactions per second. And to compare with the Visa we use every day, at its maximum, it can process about 56,000 transactions per second. And another figure, during last year, the Alipay, during its peak time, it can process 120,000 transactions per second. So you can see the transaction processing time for Bitcoin is at order of magnitude slower than that. So a lot of researchers is looking at how we could redesign the whole network, the blockchain platform, to make it faster. The second layer, I say, is overlay service. What does it mean? It's actually a basic application based on the cryptocurrencies. For example, they create a digital wallet. Let's say if you want to purchase the Bitcoin and you don't know where to purchase from, so you just search Google and there are a lot of services. Or you can purchase Bitcoin through our platform. We create a digital wallet for you to store and to do transactions. That's an overlay service. Second is about simple exchange. I want to transfer money to my family overseas. You can do so. And also custom merchant solutions. For example, how do you allow the people to purchase some physical goods through Bitcoin? This is all kinds of overlay service. But what we should really focus on and that make an impact to the whole industry and the enterprise is the third part. It's the value-added service. So that is all kinds of unique business applications that we need to consider. Take, for example, that smart contract. Most of you may have heard of that. It's just a piece of code that's written down what have the rules that need to be taken as similar as the normal physical contract. It has been widely applied during current industries. And another application is that we need to look into different industry-specific use case and to solve that and to change the way blockchain is actually performing different from the traditional Bitcoin platform. So this is the part we need to look into. And I believe this will be the changing factor for the next decade. With that much talked, we need to think at the very fundamental layer is that what exactly is a blockchain and how we categorize that. So most of you may have heard of a Bitcoin blockchain. So here I want to clarify that Bitcoin and blockchain are 2 totally different concepts. So they are not the same thing. Bitcoin is just one application on top of blockchain. And blockchain is the fundamental technology that enables the cryptocurrency. So you may have read a lot of types of blockchain, such as permission versus permissionless, public versus private. Well, here I provide one categorization. Here, I'm not saying this is the only way to categorize Bitcoin, the blockchain, but it's what I feel that is easiest way to understand that. So it's a two-tier, it's a three-layer categorization. So you will have permissionless and have permissioned. So from the name, it actually suggests quite well. So permissionless, that you don't need anyone's authorization or grant you access. You can directly plug into a network. For example, the current Bitcoin blockchain network. That means later this afternoon, I can plug in this exact computer into the network, download whatever the transaction there, and start my mining, start my verification. And you sit down there, don't know I'm actually there. Okay? It's a permissionless. No one needs to grant me any access rights to that. I can join, leave at any time. So the key properties: public read, public write, and public verify. Public read means I can see through all the transactions. Public write means I can start mining and possibly write into the blockchain. And public verify, that means I can verify the transaction happening in the past for the whole duration of the blockchain. So you can have the traditional Bitcoin platform. Another permissionless platform is the Ethereum. So Ethereum is another smart contract-driven blockchain platform that gained quite a lot of popularity recently. Coming down, we have permission blockchain. That means eventually someone is going to grant you some access to the network. But it depends on what kind of functionalities you may have. So we further categorize into public and private permission. So you may notice that I have a quotation mark there on the public. The reason being that it actually depends on us or the person who designed such a blockchain, what exactly does this public mean? Will it be the same as the general public, as our laymen could access anytime? Or it could be a public that restricts to a set of peoples. For example, there are 10 companies collaborating on a simple project, and all the employees under these 10 companies could access the network. Well, the people who design such a network can call this group of people as public with quotation mark. So it depends on how we define that. So for a public permission, we could have this quotation marked public read. People should have this basic functionality. Well, not everyone may not need to write into the blockchain. Only a few nodes may. But it should allow this public verification. For the private permission, it's the most easiest to understand. Everything is constrained in the network. We have private read, write, and verify. So under this permission blockchain, I just named two examples. One is Hyperledger, which is founded by the Linux Foundation and supported by a group of enterprise giants. So what they are designing and implementing is to enterprise blockchain solutions to suit the specific use case. And they allow different functionalities to be built upon this blockchain network. And another example is Ripple. So it's critically related to the financial industry, and they have their own cryptocurrency called XRP. So you may notice that I have another name, R3, here at the bottom, which doesn't fall under any of the category here. And I believe a lot of you have heard about that, because last year, MAS, Monetary Authority of Singapore, actually signed a collaboration with R3 to reshape the financial industry in Singapore. However, strangely, R3 claimed that they are not building a blockchain platform, but they are using blockchain technology. So it's a bit confusing for me, because I look through their protocol, they actually follow the standard technology, for example, the hash computation, digital signatures. So the message I want to convey on this slide is that there are so many ways that you can define a blockchain, and the concept today surprisingly becomes quite vague. That depends on how you argue it. Yeah, from maybe tomorrow, like people say, wow, Sula, what you have doing here is totally wrong. Well, I won't argue with him, because it depends what is your specific use case and how you restrict the people who can have these three functionalities. Well, with the knowledge of how we categorize this blockchain, the next step is, do I need a blockchain for my enterprise? Okay. This is a very critical information you have to think before you do that. Okay. don't go to the blockchain because that it's quite a hot topic today and I want to deploy on in my company. So here, I provide a simple questionnaire that is designed by 2 researchers from Switzerland. Okay, they published a paper earlier this year. So they ask you a series of questions to help you and to guide you through and to find the best suitable blockchain type you need to do. Looking at the top left corner, the first 3 questions are relatively easy to understand. Do you need to store data? Yes. Do you need multiple writers? Most likely, yes. Do you always have online TTP? TTP means trusted third party. Well, probably no, because I probably don't have the time and the cost to hire a middleman to mitigate and to resolve all the dispute. So easily we can come to the 4th question. So this is really the management need to consider. Does all the writers known prior to the system setup? For example, for Bitcoin blockchain, no. The answer is no, because as I mentioned, I can plug into the network later this afternoon, and you don't know that. But for a lot of enterprise use case, the answer is yes. I know who is going to contribute into this blockchain. The next question is, do you trust all of them? Well, this is, might be a difficult question to answer. If you want to design a blockchain within your enterprise, probably high chance is yes. But if you are starting a project that collaborating with quite a number of partners, well, you could only have very minimum trust. And sometimes he could change the record or whatsoever, and then you have endless dispute. And the last question is, do you need everyone to see that? So I said the last 3 questions are the most challenging to answer. And it has to be designed specifically for different use case. And with that, you can choose the most appropriate blockchain type. Let's look at an example and supply chain management. I want to give a concrete example here. Let's say Apple is going to launch iPhone 8 soon, later this year. And what Apple did is that for iPhone 8 or iPhone X, someone say, first thing, I have to purchase all these raw materials from different vendors. The batteries, the chips, the screens, from all the factories. Then all these components will be shipped to the assembly line, say Foxconn in China. Then after all this iPhone has been assembled, it will be distributed globally to all the warehouse. And then the warehouse will distribute to their physical retailers and eventually goes to the customer hands. So Apple, sit at the top, currently is actually overseeing the whole process. All the information is actually centralized to Apple. This is actually quite an inefficient way of doing business, because in this centralized system, there are 3 drawbacks. First of all, you have a single point of trust. That means everyone needs to rely on Apple, right? Apple needs to respond for whatever queries. Then the ambiguity of record during dispute. For example, Foxconn shipped 100 iPhone to warehouse A, but second day the warehouse say, hey, I ordered 200, but why only you ship me 100? Then Foxconn say, hey, here is my contract, then you only order 100. Then there's a dispute. It is quite inefficient, and people need to resolve this kind of thing. Last but not least is weak fault tolerance. So that means if there is a single point of failure, the whole system will break down. Okay? So if you recall what we have mentioned in the previous slide and looking at the supply chain management example here, you may say, well, this is a suitable case to use blockchain to solve the problem. I do have information to store. I do have multiple writers. I don't really have a always online trusted third party, right? But I can manage who will access this and who will verify that. So I eventually probably will choose either a public permission blockchain or fully private blockchain. So with that distributed ledger, we have reduced trust model. We probably don't need to trust each other so much. We have the efficient state tracking and dispute resolution. Last but not least, we have all this verifiable and non-repudiation of transaction records. That means whatever recorded in the ledger is there. You cannot refuse that. It has happened and verified by the nodes in the network. So with all that much said, the blockchain is happening right now, but we do have a lot of challenges need to be resolved. For permission blockchain, it's slow and efficient, I mentioned just now. It's difficult to push upgrades because there's no one managing that. It's purely by the whole community across the world. So people have to discuss from time to time and post on online forums and to formulate what needs to be changed. It lacks of enterprise support because actually, let's say today I'm plugging into the blockchain platform and tomorrow I lost my 1 Bitcoin, then I have nowhere to cry because no one cares about you. You have to figure it out by yourself. No one is going to support you. Last but not least is private issue. So although the Bitcoin that you're using a kind of public key cryptographies that avoid traceability, but still, if that identity is exposed, people will be able to know how many Bitcoin you actually you own, and there's a privacy issue there. What we are more interested in on permission blockchain. So first of all, is the solution robustness and viability. So as I mentioned many times, we have to design the specific solutions for different enterprise use case. Second, functionality and functionality richness. For the specific use case, to what level and to what functionality I want to achieve, this has to be designed specifically. Third, it's not just design a system. You have to integrate with your enterprise. For example, in this industry 4.0, a lot of factories trying to use blockchain, but whether it is suitable and how difficult it is to integrate with all your machines, your sensors, your operational softwares, it's a big question mark there, and it takes a lot of effort. Fourth, it's the technical support. It only provided by the designers only. So you can see the fourth point here and the third point here actually contradict to each other. So if you are going with a permission blockchain, good, you may have 24/7 response, but it's only constrained to the set of people who design that. Okay, whatever they say, you have to admit that. You have to take that. But for the whole blockchain, eventually people will discuss and to evolve and to fix whatever the problem is. Last but not least, privacy issue. You can see the privacy here is actually applied to both permission and permissionless. For example, the smart contract. A lot of enterprises are trying to automate the whole process they doing business. But if they run this process through smart contract on the Ethereum, the people across the network actually is able to see what you are doing. And this is definitely the company and enterprise don't want to see. And researchers is actually working on that to solve the problem. So with that said, I want to say what we are, Institute for Infocom Research, we are doing right here. We are working on 3 big parts: blockchain with network. So for a network, you have a lot of nodes, and it naturally forms a network, distributed network. So all these transactions of the network information or whatsoever, you can try to mimic that as transaction. Second, blockchain and IoT security. So we can foresee that in the next decade that at your home, perhaps there are dozens of IoT devices. They are interconnected to each other and form a network. How they communicate with each other, and how are you assured that this communication actually is secure and no one is manipulating your home network? This is what we are working on. Last but not least, as I mentioned, privacy preservation is actually the key research areas, and we are looking into that. So to end of my talk, I want to highlight the key impact for blockchain technology to our life. The title I hear here is how blockchain is affecting us. I'm not saying will affect us, because this is happening right now. For our common people, well, money transfer is easier. Western Union may need to change their way of doing business. because perhaps next year when I just click my phone, I can transfer my money back to China, and then with very, very low commission fee there. Second, as I mentioned, home IoT network, how your devices are secured and transparent to you. Last but not least, your electricity bill may be cheaper, because with the smart grid technology, all these things can be automated, and the whole smart contract can see, okay, this factory nearest to you actually generates more electricity than it can consume, then it ships to you directly instead of going to a centralized location. On the right side, I want to stress on the impact on the enterprise. The sentence I put here is that this is a totally disruptive technology. Disruptive technology. You may notice that I didn't list the specific industry to be affected because it is actually affecting all. It's actually changing how people manage their business. Instead of centralized way, you may have a totally distributed way. Second, it changed the way people collaborate with each other. I probably don't need to have a full trust with you, but I know the technology will support me, and I can rest assured. Last but not least, many jobs may be disappeared. For example, say financial audit. What they do is to check a sequence of rules and whether you have complied all these rules and how much money you have paid, tax you have paid, et cetera, et cetera. Thinking another way, this actually can be computerized and written into program code. And everything can be realized through smart contract. The only concern that this hasn't been widely deployed is because of the privacy concern. Of course, I don't want someone across the network know how much I earn and how much tax I pay for each year. But with the technology, particularly cryptography supported, once the privacy issue has been resolved, the whole thing will change. I don't need to pay a lot of money to an auditor to look into my tax. Everything can be done through in an automatic fashion. I can save a lot of money. So with this all said, if we sit down and look back for 2 decades ago, the things changed our life is internet. I remember at my age of 10 plus, first time I connected to the internet, I read news across the network, across the globe. And it changed our life for a decade. 10 years ago, we have the cloud. So we start moving everything to the cloud, and we can access it from anywhere. And today, we can do a lot of more things on the cloud, computation, analytics, whatsoever. And today, we not only have blockchain. It's just one of them. We also have big data. We also have artificial intelligence. These are all disruptive technologies that is affecting our life. They are not standing alone, but interconnected with each other. The big data is affecting how blockchain is going to form, and the full automation of blockchain is going to help the AI to predict what is going to happen for autonomous vehicle. So I want to summarize is that perhaps what we've seen today, the blockchain may not change our life or impact our life as big as internet and cloud during the past decades, but the blockchain is changing the way we do business. That ends my talk, and thank you.